guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at a short summary of one of the processes of obtaining sodium carbonate. And in our last discussion, we had mentioned a few or a number of uses of this specific compound referred to as sodium carbonate. Now, in some of our texts, we are going to come across it referred to as soda ash. And of course, this is going to be finding relevant applications in our day-to-day, perhaps industrial processes like manufacture of glass, laundry and detergents, domestic softening of water, and of course we're going to see that in chemical and chemical manufacturing like sodium hydroxide and textile and paper manufacturing, of course, are going to find a relevant application of this specific compound. Now in this case, we are going to use another process of obtaining this sodium carbonate through the extraction from what we refer to as Trona. Now this specific compound referred to as Trona is a double salt, and of course which is going to consist of sodium carbonate and the sodium hydrogen carbonates which are hydrated. So we can give this one in terms of this specific salt. So we're going to have sodium hydrogen carbonate and sodium carbonate, of course, and this one are going to be in a sense, so we shall just have this one as a complex or just a salt given as such, which is a double salt, which is hydrated, of course, and of course this is going to be referred to as Trona. Now when this specific compound is heated at a temperature of 200 degrees Celsius, it's going to decompose and form sodium carbonate, which is soda ash. So we're going to have a general equation whereby we're going to have this sodium carbonate or a Trona undergoing decomposition, and of course we shall have, so this is going to be sodium carbonate, hydrogen carbonate specifically, and this is going to be hydrated shown as so this is going to undergo a decomposition at 200 degrees Celsius, and this is going to lead to the formation of a sodium carbonate given as that. So we shall have this one given as such. So these are going to be three. We shall have a schematic of course, or a stoichiometric equation given as such, and this is going to lead to the production of water, of course, and carbon 4 oxide given as such. So this is going to be liquid. Then presume that this equation is balanced. So this is going to be the general equation representing the production of this specific compound of course, sodium hydroxide from what we refer to as Trona. Now this Trona is going to be decomposed to form carbon sodium carbonate, and of course this is one of the ways in which we can obtain the product of sodium carbonate from what we refer to as Trona. Now of course this is going to form a final bit of the various reactions which we have looked at for group 1 elements, and especially on the essential parts of or essential compounds which are going to find wide application in our day-to-day, of course, applications. So catch us in our next videos where we're going to look at the group 2 elements and some of their compounds. And of course, we shall look at a number of reactions which are going to be resulting in the formation of various products which are going to also find relevance in our day-to-day application. So that is it for now, guys. Bye, God bless you. Catch us in our next video.